Welcome back to gas laws. Here we are going to be dealing with a little bit higher level. We're going to be combining a couple of things now. So with that being said, combining means we're going to be working with the combination gas law. So that's going to combine our two previous concepts into one gas law. So let's take a look at this problem. A 25 milliliter bubble is released from a diver's air tank at a pressure of 4 atm and a temperature of 11 degrees centigrade. What is the volume in mLs of the bubble when it reaches the ocean surface where the pressure is 1 atm and temperature is 18 degrees centigrade? So we need to first start by taking a couple of notes. So we see here we're dealing with a volume. There's a volume here, okay? It says that we have a pressure and we also have a temperature, okay? So we've got three pieces of information within the first sentence of the problem. So it's saying this lets us know this is where it began. This is where all of these things began. The problem began here. Then it says, what is the volume in mLs when it reaches the surface? So this is later on. This is going to be the final amount. So let's go ahead and start labeling what we have. We have a V1, okay? We have a P1 and a T1. So if we have 1, we're going to have 2, okay? So a V2, a P2, and a T2, okay? So V1 is 25 mLs, and that's directly from the problem. We have a pressure of 4 atms, and a temperature of 11 degrees centigrade. Now, one thing we know, the standard of temperature in gas laws is going to be Kelvin. So this will need to be changed. We will need to add the conversion factor of Kelvin to our centigrade here. So we're going to do that by adding 200. Let me get another color. We're going to do that by adding 273.15. Okay? So that's going to change our temperature from 11 degrees centigrade to 284.15 Kelvin. Okay? And let's continue. What is the volume in ml? So this is what we're solving for. And let's put the unit that they're asking for so we don't forget. Make sure that we convert it if necessary at the end. And it says the pressure is 1 atm. Okay? And the temperature is 18 degrees centigrade. So just like before, we need to add that 273.15 to get it into the correct version of the temperature necessary to solve combined gas laws, okay? Or any gas law for that matter. So 273.15 plus 18 will give us 291.15 Kelvin. Now that we have all of that, we can now revert to our formula sheet and take a look and see what is the combined gas law. What does it entail? Well, the combined gas law states that there is a relationship between the initial pressure and the initial volume divided by the initial temperature that's going to be a direct relation to the second pressure, the second volume, and the second temperature, or the final temperature. Okay? But we know we're solving for V2. So we're going to have to do some changing of our base formula in order to solve for that. So we are solving for V2. So the formula to solve for V2 is going to be P1 V1 T2. As you notice, that T2 from the base formula has gone up top. Okay. Then we now have our T1, which is still in the original position, but we now have our P2 that has reciprocaled or dropped down to the bottom. So now let's do our plug and chug portion using our shopping list. Let's go ahead and get started. Move that up just a bit. Okay. So let's start. We have V2 equals P1. My P1 is 4 ATM. My V1 is 25 ml. And my T2, because I've changed it to Kelvin, is 291.15 Kelvin. And then we're going to divide this by something. Our T1, which is also been converted, 284.15 Kelvin. Also going to be multiplied by our pressure, which is 1 ATM. Now that we have everything plugged in, we can go ahead and start the process first of crossing out like terms to make sure we have everything in the version that we need it to be in to work it out. So we have Kelvin for our temperature, so we're good. Both of our pressures match. So let's cross out some terms. I have an ATM here and here. I have a Kelvin here and a Kelvin here. And look, I am left with the ml that the question is asking me for. So we're going to plug these in to that very simple calculator. Okay. So the top number that we're going to have okay. Then 284.15 times 1, of course, is going to be 284.15. Once again, back to our trusty calculators to help us along the way with these numbers that are a little larger than we normally deal with. And we're going to end up with 102.46 348. Now, I would not want to try to determine or pull up, that amount of volume. So we're going to go ahead in this sense, and we're going to round this to the nearest tenth. So we have to look at the hundredths place to determine if this is going to go up by 1 or stay the same. So anything 0 to 4, it stays or it goes down to 0. And the numbers 5 and above, or 5 to 9, you would round up. So here we have 0.46. This would now become 102.5 mm